All right, so this class will be a bit of housekeeping first. This class will be no longer than 1 hour, so I'm not going to go beyond 5 p.m. It's a level 100 introductory class. Some technical knowledge is assumed, however, no AWS knowledge is assumed or required here. The agenda that we're going to cover is what is cloud computing, right? I mean, that's the very first thing. Cloud computing is this new fancy marketing term to many. So, what actually is it from a technical perspective? Then we discuss the AWS global infrastructure. Some foundational services you may or may not be aware, but AWS has over 200 services, and I'm going to discuss on a technical level the most salient of these. So the most important ones, the foundational ones. We then talk about EC2. You've heard of this thing. What is EC2? I want to dive in a little bit deep because personally, I feel that EC2 is probably our most important service to be familiar with. And then finally, we end up with Q&A. Now, I don't want to make it feel like that Q&A has to come at the end. If you have any questions, please either jump off mute and interrupt. You're more than welcome to, and ask your question. I would appreciate if I could see who's asking the question, so come onto video. Or you can use the chat window. Now, I can't see the chat window in this presentation mode. However, Carolyn and likely Mike as well are there, two Amazonians that are going to help me with any typed questions. So, Carolyn, if you don't mind, if anyone types any questions, you can jump in and ask it on their behalf. Now, before we go any further, I just want to make sure that everyone's a little bit familiar with the WebEx tools that you've got in front of you. At the bottom of your screen, you should see two buttons. One of them is called Reactions, and another one is called Raise Hand. In the reactions, if you don't mind, just do a thumbs up so I know that people know how to use that functionality. Okay, I don't see it on my screen. If you guys are doing, oh, there we go. Yes, I see them popping up. Thank you. And if you've got a question, you can do a hand raise as well, although it's quite small on my screen and I might not see it. So just typing the questions is probably better for me, and Carolyn can help ask them. All right, so let's dive straight in. All right, what is cloud computing? Um, if you ask 3 different people what is cloud computing, you normally get 3 different answers. Right? And none of them are wrong. It's so cutting edge that no company or industry has really defined exactly what it is for everyone. However, I can tell you what Amazon considers cloud computing. So as far as Amazon's concerned, or AWS, cloud computing is the on-demand delivery of IT resources and applications via the internet with the pay-as-you-go pricing. What does that even mean? So personally, I like to think about cloud a little bit like I think about handbags. So I've got a sister, her name is Jazz, and Jazz loves handbags. In fact, she's got a wardrobe full of them, and some of them cost thousands of dollars. So you've got your Louis Vuitton, your Gucci, right? You've got your Chanel's, all those brand name ones. And as you know, uh, fashion can be mercurial. So what Jazz does, she buys the handbag, she uses it for as long as she needs it, but then fashion kind of moves on, and the handbag ends up in the back of her cupboard, gathering dust, right? Hardly used again. And this can get quite expensive because it's a repetitive, vicious cycle for Jazz. And she was really dumping a lot of money into handbags. That is until she came across an online handbag hire company. Now, there's quite a few of these that exist, right? You just jump onto your favorite search engine and you type in online fashion hire or online handbag hire, and you'll find a website that will allow you to sign up for free, put in a name, sign up for free, put in your credit card details, and then it will provide you this smorgasbord of handbags for you to choose from. You choose whatever you like, and they'll give you a 4-day rental, 8-day rental, 2-week rental. You get to choose. And the nice thing is that when you get the handbag, you only pay for what you're using while you're using it. You only pay for it while you're using it. And when you're done with it, you give it back and you stop paying. Now this is powerful on its own, but there's another benefit here. Jazz now has access to handbags that she could never afford before. Tens of thousands of dollars worth of handbags, right? In AWS, our customers have access to servers that are worth hundreds of thousands of dollars, servers that we could never afford if it weren't for AWS, and yet we can use them for cents on the dollar. Right? So that's quite a powerful paradigm that cloud has created. So here's the thing, we only pay for what you use. You have an access to a wider range of products, including some products that you could never have afforded on your own. And on top of that, they do the maintenance for you. So AWS manages the infrastructure on your behalf. This is how I like to see AWS, the handbag hire company of the cloud. Now, before the cloud, we used to house all of our servers in a data center, an on-premises data center, the one that you see on the left of the screen, right? And then along came the cloud, and this was specialized buildings with rows upon rows of these stacks of servers stacked beside each other. And then along came the cloud, which is this ephemeral, puffy thing that you see on the right-hand side. Now, what is the difference between the two? The truth is, there is very, very little difference when it comes to what hardware we have in both of these things. Right? However, the limitation for on-premises data centers is that it isn't flexible. There is an upper limit of how many servers you can manage in there and how many servers you can manage with the team that you currently have. And even if you have room, the procurement life cycle, meaning the life cycle of when you go from approved budget to purchasing the equipment to installing the equipment, then eventually operating and managing the equipment, is quite a long one, and it's a matter of months. Whereas with cloud, you can provision things with a click of a button, and it happens within a matter of seconds. But the point of this slide is to show that the hardware really is pretty much the same. Now, AWS, on the other hand, has a extremely large global presence. What you see in front of you is the number of data centers we have across the planet. We have 26 of them. We call these locations regions. So what is a region? A region is a large geographical area such as Sydney or perhaps Singapore. Let's zoom in a little bit. So here we have an example region. This is the Sydney region. Now, every region begins with at least 3 availability zones, or what we call AZs. What is an AZ? An AZ is a cluster of data centers that act as one large virtual data center. Furthermore, an AZ is every AZ. So we've got AZ A, B, and C on the screen there. Every AZ is isolated from every other AZ. Isolated how? They are on separate redundant power sources. They're on separate internet service providers. They're on separate floodplains. They're on separate tectonic plates, if it applies, and they're tens of kilometers apart from each other. So what's the benefit? What's the purpose? The purpose is just in case one of these AZs were to go offline, then the other AZs will be able to pick up the slack and keep running. So let's do a quick example. Here I've got in AZA, this little orange icon is my server. I've been running this web server perfectly happily. Along comes a meteorite and smashes into AZA and completely wipes it off the face of the earth. What happens to my web server? Well, it disappears with that AZ, and my customers are unhappy because now they can't access my server. What's probably a better idea to do is build the web service across the AZs. So I've actually got duplicates of AZA, B, and C, of server in AZA, B, and C. And now if a meteorite were to come and smash into AZA and wipe it off the face of the earth, my application can plod on along happily in AZs B and C. Okay, in addition to the regions, we also have over 400 edge locations globally, scattered across the globe. You can see it on the map there. Now, this is not the most up-to-date map. That's not 400 dots that you see there. We've got a lot more of them now. I'd like you to consider these edge locations as entry points to our AWS global network. Okay, this is what we use to bring our customers closer to the AWS network. Let me show you an example. So here we have a cloud labeled AWS. This cloud represents every bit of fiber, copper, silicon, metal, everything that AWS owns globally is all represented within this one cloud on your screen. So you can imagine it is a massive, massive cloud. There is only one cloud that's bigger than the AWS cloud on this planet, and that is the internet. The AWS cloud lives within the internet. Now, these edge locations live, as the name suggests, along the edges of the AWS cloud. And I'd like you to think of it as if they've got two legs. These edge locations have one leg inside the AWS cloud and one inside the internet. They get traffic from here, they send it here, they get traffic from here, they send it here. That's their job. Here we have a user. He's in Germany. He wants to access a server in Australia. How does he get into the AWS cloud to get to Australia? Easy. The closest edge location to him, which happens to also be in Germany. And the benefit here is as soon as he hits the edge location closest to him, he is now inside the AWS cloud. And so we can optimize that connection for speed and reduce latency. I'm going to stop there for a second and see if there are any questions.
I don't have any questions in the chat box, but I am checking it out. But if you also want to come off of mute, please feel free to do so.
Please.
Sorry, can I ask a question?
Absolutely.
Um, as you mentioned, AWS has a AWS Cloud living in internet. So I'm wondering, so does it mean all the physical infrastructure within AWS's cloud owned or totally owned by AWS?
So if I just go back here, so that AWS cloud that I showed you inside the internet, that is owned and operated by AWS. Now, does that mean that every single piece of it is? There would be, without a doubt, some co-located locations across the globe. However, meaning that the space that we've hired to house our infrastructure is a hired space, but we have absolute control over the hardware that's in there. And so, as far as our customers are concerned, this is owned by AWS and managed wholly by AWS. We don't share say, for example, if we quite literally have laid cables from across the oceans, and that's our cables, that's our bandwidth, and then we use that for the AWS backbone. If you're interested in finding out more, jump into your favorite search engine, type in AWS Global Infrastructure, and also on YouTube, there is a video by Mark, I've forgotten his surname, but if you type in AWS Infrastructure Mark, you should find the video where he talks about all the fiber cables that we lay across the oceans.
Yeah, thank you very much.
My pleasure. All right, let's move on. So far we've been talking about the global infrastructure. Now let's discuss a few of the foundational services. But before we do, I'm going to ask you a question. I guess it's a rhetorical question. It is, who here has played with Lego as a child? Obviously, everyone has played with Lego as a child. Lego is amazing. I have two kids. They love it. I love it. I'm not ashamed. But what is Lego? It's just a plastic block, right? In fact, it's just a bunch of plastic blocks. You got your long block, your fat block, your round block, your thin block, your square block. But the power of Lego doesn't come from these blocks. The power of Lego comes from the way in which you can attach these blocks together. It comes from the freedom of building whatever you want, and your imagination really is the limit, right? Here we have a few different things that you can build. My son is into Star Wars these days. He absolutely loves it. AWS is just a bunch of blocks. You have your long block, your thin block, your round block, your square block. But the power of AWS doesn't come from these individual blocks. It comes from the freedom to build whatever you want by connecting them together in various ways. And your imagination is the limit when it comes to AWS. How many blocks do we have? We've got over 200 different blocks. Today, we're going to go over only a handful of them. These I consider the most salient blocks that you should be aware of before diving any further into AWS. And you can break these out into 4 different categories. We have compute, networking, storage, and database. Okay, let's discuss compute first. I'd like you to think of compute as just a fancy way of saying data processing. That's all it really is. And here we have a server. This server is what we call an EC2 instance, and it's hosting a website called blueorigin.com. If you're not familiar with it, Blue Origin is Jeff Bezos's rocket company. So it's hosting this public website. Now, these servers, these instances, consider them the workhorses of your infrastructure, of your architecture. Consider them at the coalface. They're the things that are actually plugging away at computations, processing all of that data. Here we have a user that is accessing blueorigin.com. So far, everyone's happy. But then more users come online, and you see that the capacity of that server is beginning to go up. But then more users come online and that capacity continues to go up. Now, every server has its absolute limit, right? At the end of the day, it lives in the real world. It has to have an upper limit. And if you have enough pressure on this server, the server is going to fall over and start dropping connections. That's not a good thing. And customers begin to notice, and you end up with angry faces. So what do? Introducing autoscaling, another block. The purpose of life for autoscaling is to notice when the pressure is getting too much, and before it gets to absolute capacity, its job is to add more resources to be able to handle more load. And we can adjust this automatically in both directions. So as the load increases, we can add servers, but also as the load decreases, let's say a couple of those customers decide to go to bed, we also reduce the capacity. Now, this is all done automatically. We automatically adjust the amount of resources we need to suit the demand at the time. Now, let's introduce networking. This is the plumbing of the internet. It's our ability to direct the flow of data to whichever direction or route we choose. There's 3 services here I want to discuss: Elastic Load Balancer, Route 53, and CloudFront. But first, Elastic Load Balancer. Now we're back to our web service. So how does the traffic actually know which way to go? Right, we've got 3 servers there. Which one is it going to go to? This is where Elastic Load Balancer comes in. Think of the ELB as a kind of traffic conductor for the connections so that they know which path to take. There we go. Now, for the more astute students here, you're thinking one thing, alarm bells are ringing in your head, and you're thinking to yourself, whoa, 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 whoa. The last thing I want to do is introduce this single point of failure here, because it doesn't matter how many servers I have in the back end maintaining my availability. If this thing decides to die, then these ones in the back are simply not accessible. Ah, yes. Well, that's what it looks like. That's because we like to draw it like that just to make it look nice. But in reality, an elastic load balancer or an ELB is a fully managed service. What does that mean? It is fully managed by AWS. As a minimum, there are two servers in the backend. If one of them does fall over, the other one carries the load, and we spin up another one to make it a nominal amount of two servers in the backend. This makes it highly available. In addition to that, if there's more and more load coming into your service, the elastic load balancer will increase the number of servers in the backend to handle that load so it never falls over. And then it will also, of course, decrease the number of servers back to a minimum of two so that as the demand is reduced. In addition to that, the elastic load balancer will live across all of your availability zones. So even if an availability zone falls over, the ELB continues to operate. Now, the nice thing about this managed service, and I'm going to plant a flag here, managed services are a big thing in AWS, right? You'll come across a lot of managed services. The nice thing about a managed service is it is AWS's responsibility to make sure that the availability and the security and the scalability of that service works. It's no longer the customer's responsibility to do that. And we provide certain SLAs to make sure they're met. Then we have Route 53. So Route 53 is our DNS service, our domain name service. If you're familiar with that, you'll know that it's essentially um, pardon me, it's essentially a um, a resolution service, meaning here I've got my phone. If I want to call my friend Jim, I don't need to remember Jim's number off the top of my head. I just type in his name, and the phone does the resolution for me. It turns it into a number. So Route 53, what it does, it grabs the domain names that you type in this case, nasa.gov, and then it turns that into NASA's IP address. But Route 53 is so much more than simply domain name resolution. We have we have other functions or features within Route 53. One of them, for example, is called geolocation-based routing. How does this work? Let's say, for example, a pardon me. Let's say, for example, we have our customer in Russia wanting to access our server in Australia. I could have blacklists and whitelists in there that say, I do not want anyone who's coming from Russia to access my server, but I will allow everyone else, for example. We also have this thing called latency-based routing. So if I've got my server sitting in Australia and I've also got a duplicate of that server sitting in the west coast of America, I obviously want to make sure that the customers go to the server that's closest to them, right? The shorter the wires, the quicker the connection. So we want to reduce the latency. If I have a user coming in, let's say from Singapore, Route 53 will automatically resolve to the server that's in Australia because it's closer to that user in Singapore. This is known as latency-based routing. And then finally, we have this service called CloudFront. CloudFront is our content distribution network. So if you're familiar with the likes of Akamai, just think Akamai. That's our version of that CDN or content distribution, sometimes known as a content delivery network. So as I told you before, we have over 400 edge locations globally. Um, think of them as a point of presence of AWS scattered across the globe. At every one of these edge locations is where CloudFront lives. All right, so a small number of services live at these edge locations. One of them, one of the major ones, is CloudFront. I'm going to step through an animation to show you what CloudFront actually does if you're not familiar with the content distribution network. So here, beside Australia, you can see a user. This user is in Perth, wants to access a server, blueorigin.com, which is in the west coast of USA. What happens is the request is routed to the closest edge location to that user. Remember, we spoke about this earlier. CloudFront, living at that edge location, asks itself a question: have I ever seen this website before? The answer is no. And so the request is sent all the way to America, and the response comes all the way back from America. CloudFront does two things. Number one, it saves a copy of the response in its local cache on its disk. And then number two, it sends a copy of that response back to the user. And everyone's happy. Transaction complete. A little bit later on, that same day, another user comes along, also in Perth, and says, I also want to go to the same website. And they also hit the same edge location, which is closest to them. And again, CloudFront asks itself the same question. Have I ever seen this website before? This time the answer is yes. And CloudFront will actually give a copy of the local response to the user. Now, you can imagine in the first case, the latency between here and here is going to be much, much higher than the latency between here and here. Now imagine this paradigm spread across 400 plus edge locations all over the globe, and you can begin to see the power of CloudFront, our CDN. Here is a case study by NASA, a NASA case study from 2012. I don't know about you guys. I am a massive, massive space buff, massive space buff. And I remember when they were launching the Mars Curiosity rover in 2012. Right, and this was that rover that was the size of an SUV, and it was it was a pretty big event at the time. We've done it once again since then recently. So, and at the time we had sent rovers to Mars before. So what you're probably thinking, well, why is it such a big event? In the past we would send rovers to Mars. What we would do is would sort of fold them up, would put them inside bubble wrap, we'll throw them at the planet. They'd bounce across a few times and then eventually deflate and just drive off and do their sciencing. Uh, with this particular rover, it is the size of a massive SUV. It's nuclear powered. It was huge. You can't just wrap this thing up in bubble wrap and throw it at the planet. It'll get crushed. Instead, there was this huge engineering genius maneuver that they came up with to try to get this machine onto the planet. If you're interested in how they did that, go to YouTube and search for Mars rover 7 minutes of terror. Okay, and you'll find the video. It's about a 4-minute video. Anyway, so NASA was saying, hey, we're going to do this thing. We're going to drop this machine onto Mars. And about 3 months before the ship actually arrived to Mars, before this whole sequence began, they stopped and they realized, they go, oh, hold on a sec. We want to stream this event live globally, yet we don't have the global infrastructure to do it. And we're only 3 months away. How are we going to do this? They reached out to AWS and said, hey, can you help us out? We said, absolutely, we can help you out. And we were able to design and deploy a global infrastructure within 3 weeks. We had it ready. When the time came to actually do it, I don't know about you guys again, it was 3 a.m. Sydney time. And I remember me and a bunch of my nerd friends, we were all watching it. It was a very, very exciting event. And it went ahead, streamed, as in it was streamed globally without a single hitch. We managed to, using CloudFront, to distribute 175 terabytes within 3 hours across the planet. And then when we were done with it all, we wrapped everything up inside a ball and we threw it in the bin, never to be seen again. And NASA stopped paying for the architecture. That's just marvelous, in my opinion.
Eddie, as you're changing slides, there is a question in the chat that I wanted to throw out to you.
Hmm. Sure.
It is, does AWS use Nginx or F5 application services to provide high availability services? If not, what is it? Thank you.
I am familiar with AMI. We'll talk about what an AMI is later on. If you're familiar with it, then great. I do believe we have AMIs that have Nginx built in. I am not familiar with an AWS version of that. I do know that we do support Nginx. So Nginx is the software that runs on your servers. You can still run that in an AWS environment, and I'm almost certain. maybe Mike, I'll get you to confirm that and put the answer in the chat. I'm almost certain we already have an AMI that includes Nginx as well, just to make it easier to get started with it. As for F5, um, sorry, was that F5 load balancers are you talking about, or you're something about F5 application something?
My assumption was it's load balancers, but it does not say. Maybe let's see. Jan Kin, I'm not sure if I'm pronouncing your name correctly. I'm sure I am not. I apologize. But if you would not mind coming off mute and clarifying for us.
Yeah, can you hear me now? Sorry about that. Yeah, so yeah, it is. So F5 services.
I can barely hear you, Eddie. I don't know if you're able to, but I can
can't
just
hear you.
barely.
No, I'm sorry, I can't hear you. You'll have to put your mic volume up. Shall we table this for later, and cover it once we get to the end, if you don't mind? So there is a Q&A section at the end. I'll bring it up
Yep.
then. I'll have your question ready, and then I'll answer that, if that's okay. All right, let's carry on for now. We've done CloudFront. Let's talk about S3. S3. S3 is our simple storage service, 3 S's, S3. So let's go back for a moment to our server over here. This guy's at the coalface, right? Remember I said before, they're at the coalface. They're actually there doing the computations. They're the brute force. They're the muscles of our application. And so there they are, plugging away at the coalface. In reality, it's never going to be just one server. If it's a big enough application, you could have hundreds of servers, all of them plugging away at the coalface. And at some point, one of these, or multiple of these servers, are going to come across a nugget of data. Okay, now a nugget of data is gold. It's a unique piece of data that I do not want to lose. Okay, each machine is probably going to come up with one of these nuggets at some point, multiple times. How do they come up with it? It might be uploaded by a user. They may have generated it themselves. It doesn't really matter how they came across it. The point is that they are now holding this nugget of data in their hands, and if the machine happens to fall over and dies, we lose that data. Right? Having lots and lots of machines holding onto their own various pieces of unique data is, at best, a data logistical nightmare. At worst, we can lose data we do not want to lose. So what do we do? Well, one option is, as soon as that worker at the coalface generates a unique piece of data, they immediately put it inside a central repository, a receptacle, or what we call in the S3 world an S3 bucket. Okay, now again, S3 is that magic phrase, a fully managed service. It is fully managed by AWS, meaning it is highly available, it is redundant, it is secure. You are not going to lose your data. In fact, we are so confident you are not going to lose your data that we guarantee 11 nines of durability. 11 nines of durability. So that's 1 9, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11%. Okay, that is how certain we are you're not going to lose a piece of data. Now, that just looks like a lot of lines, at least to me. Let me put it in slightly more human terms. What this means is that for every 10 million files that S3 holds, you should expect to lose one of those every 10,000 years. Okay, that's how durable it is. So you're not losing that data. And those servers have just gone back to being two hands working at the coalface again. If you happen to lose one of them, big deal, you can replace them. So that's S3. Next we have, or finally, we have databases. Now, while S3 is a bucket, filled with different types of files, such as pictures, web page static assets, backups, videos, just files essentially. Databases are more like filing cabinets. So therefore, persistent, organized, structured set of data that can be quickly retrieved. That's what a database is for. There's many types of databases out there. There's no such thing as a one-size-fits-all. We have so many different kinds of databases, and surely one of them will suit the requirements that you have. Two of these types of databases are RDS and Aurora, and the next one is Dynamo DB. So if you're familiar with relational databases or SQL databases, that's our RDS and Aurora. RDS stands for Relational Database Service. And for your non-relational requirements or NoSQL requirements, we have Dynamo DB. Now I'm going to stop there again and see if anyone has any questions.
Nothing in the chat box, but if you have a question and want to come off mute, go for it.
I'm either doing a very terrible job and everyone's fallen asleep, or I'm doing a fantastic job and there are no questions. I'm not too sure which. All right, let's carry on. Let's dive in a little bit into EC2. So EC2 is Elastic Compute Cloud. So that's the two C's, EC2. I believe that this is our most important service. So that's why I wanted to sort of dive a little bit deeper here. So EC2 is an AWS product. You may have heard of it before, but my assumption is that you have never heard of it before this session. Okay. However, its functionality is extremely similar to things that exist outside of AWS. And so what I want to do is take a few steps back and try to explain the technology that preceded AWS and then make comparisons to the products that we have in AWS in the hopes that you can use your existing knowledge to and attach that, reference it directly to our AWS products. And the particular services or products I'm going to talk about is obviously EC2, but within that, AMI, which is Amazon Machine Image, EBS, which is Elastic Block Store, Instance Stores, and Instance Types. So here I'm going to be building a multi-layered model of a typical desktop PC, okay, like the PC that's in front of you now. We're going to start with hardware, right? Once upon a time, we had hardware. And back then, hardware comprised of CPU, that's the symbol for CPU that I've put, RAM, hard drive, and a network interface card, also known as a NIC. On top of that layer, on top of the hardware layer or the metal layer, we have an operating system. In this case, it is Windows 95. Now, the operating system has intimate and ultimate control over the hardware. Okay, it's like Stalin as far as controlling the hardware is concerned. Nothing else comes between it. These resources, the hardware resources, are used by the operating system to run things like applications like Word, Internet Explorer, etc. And everyone was happy for a while. So what companies like to do was buy a bunch of these computers, put them all together, network them together, and in the middle they'll have another PC that they would use to hold all of those important files and other information, data, backups, etc. But then this would present a problem. This computer in the middle is not designed to be a server. We need something better suited to the task. We need something like a server, right? And so what is a server? Here we have a typical server. It's got exactly the same thing as a client PC. It's the same hardware. Instead of running Windows 95 on top, we're running a different operating system like Windows NT, right? And so you can see how far back I've gone by the age of these operating systems, right? It's got a slightly different operating system on top, optimized to run services. What kind of services? Well, web server and an email server are two examples. And so here we have that architecture, but there's another problem. This server in the middle has all of my financial data, my backup data, my key, critical data, my secure data, everything stored in it. And it's living under the boss's desk in the office. What if the building burns down? What if the server gets stolen? The company could potentially fold. This data is absolutely critical. We can't just have it sitting under a desk. So what do? We throw it inside these things called data centers, right? All of our servers are now inside data centers. I don't know if you've been to a data center. I've been to quite a few. They are noisy. They are super noisy. They are really cold, although I've heard they've gotten better recently. But they're super cold. You've got to wear your bomber jacket regardless of what the weather is outside. They have these non-water fire retardant systems that just in case a fire occurs, water isn't used to put it out. Otherwise, you damage all the hardware. So they use these special ways of putting out fire, including in some cases sucking the oxygen out of the actual rooms to put out the fire. It is crazy stuff. They are ridiculously locked down. Security escorts, palm readers, they pad you down, make sure you're not carrying a camera, etc. And they've got backup generators for their backup generators. All of this comes at a ridiculously high price. So just hiring one of these racks that you see on your screen would cost tens of thousands of dollars per year. Now, this is fine because during peak period, your server is running at 80 or 90% and everyone's happy. It's perfectly fine. However, what about the non-peak periods? The capacity drops down to 10%. 20%. This capacity is wasted and it's burning a hole in your pocket. So we need a way to optimize the utilization of our servers, introducing virtualization. So back to our layered model. We start off with the hardware again. Nothing's changed in the hardware, but this time on top of that hardware, we put an operating system called a hypervisor. A hypervisor is a specialized operating system that still has intimate and ultimate control over the underlying hardware, but its role is to pretend to be hardware to allow other operating systems to run on top of it. So here we have Windows XP as a guest operating system and Linux as a guest operating system running on top of the hypervisor. So if we look back at the actual hardware, let's say, for example, it's got 16 CPUs, the hypervisor will share 4 of them to this Windows XP guest and share 4 of them to this Linux guest. The operating systems, the guest operating systems on top, actually believe that they're running on the real hardware, but really they're living in the matrix. The hypervisor is living on top of the real hardware. Okay, so and then on top of those operating systems, we have applications. So we've been doing this for almost 20 years, right? Virtualization has been the status quo for about 20 years. Outside of AWS, you might know this as ESXi. ESXi is a product of a very big virtualization company known as VMware. And they have these things called virtual machines or VMs. And VMs have 2 moving pieces, the hardware or the virtualized hardware and the software that it runs. In AWS, we call this exact same thing EC2. That's our hypervisor. And instead of VMs or virtual machines, we call them instances. And still we have 2 moving pieces for instances. We got the hardware, we call this instance type, and we have the software, we call this AMI or Amazon Machine Image. Otherwise, it's all the same. So apologies for those for the annotations there. Please ignore those annotations. They're not supposed to be there. So here we have two machines connected over a network, as shown by the black line at the bottom, and they're both running a hypervisor ESXi. The machine on the left is running a virtual machine on top of it, Windows XP. So what's happening with Windows XP, but the relationship between Windows XP and that hypervisor is the hypervisor is sharing up some of its CPU. It's sharing up some of the bandwidth of the network interface card. It's sharing up some of the RAM, and it's sharing up the hard drive. So the C drive is going up to that guest OS or the virtual machine. Now, if a meteorite were to come in and smash this machine on the left and wipe it off the face of the earth, what happens to that virtual machine, the Windows XP virtual machine? What happens to it? It's gone. The answer is it's gone, right? Can we recover it? No, we can't. Why? Because its personality was living inside this disk, which no longer exists. Its C drive, the operating system, was living there. As soon as that's gone, there's no way of recovering it again. Luckily, this is not how it works in the real world. In the real world, it might look a little bit more like this. We attach to the network this thing called a SAN. A SAN is a storage area network. You might already be familiar with it. It's been around for donkey's years. And what we do with a SAN is, well, so what is a SAN first of all? It's a collection of servers on the network that all share their disk space, collectively creating one huge virtual disk or virtual drive. And what we do is we carve out a piece of that drive, we call that a volume, and we attach that to the virtual machine. We still have the CPU, RAM, and network interface card from the underlying hardware. And now, if a meteorite were to smash into this server, wipe it off the face of the earth, can we recover this operating system? Now the answer is yes. What we can do is we can spin up another virtual machine on a different piece of hardware. We can give it the CPU, RAM, and network interface card. We can disconnect the C drive from the SAN, connecting the dead machine, and reconnect it to the new machine. Okay, remember, this is the personality of the machine, right? This is it. We reconnect it to the new machine, we turn it back on, and as far as that machine is concerned, some rude person has come up and pulled the power directly out from behind it, and it's done what we call an ungraceful shutdown. Okay, but it's come back and everything's working just fine. Now, in the pre-AWS world, we would call this a SAN. In the AWS world, we call this EBS. This is Elastic Block Store. Okay, and your instances will be attaching to a volume that is generated from the Elastic Block Store. It is highly available. It works the same or similar as a SAN. Now, there are, in some special cases, some instance types that you might still want to use the local drive. Why would you want to use the local drive? Well, the hardware is much closer to the operating system. Wires are shorter. That means latency less. That means you've got much faster access to that disk. You can still do this. We call this instance store. Okay, not all instance types offer the feature of instance store. Some of them do, but it's there if people want to use it. The benefit is it's fast. The downside is we cannot guarantee reliability. If that machine dies, the hardware dies, the instance store is gone. And so what typically happens is you've got one volume from EBS and one volume from the instance store. You put all the stuff on the EBS that you don't want to lose, and you put all the stuff on the instance store that you just want to have fast access to, but it's not critical. This is mostly used in databases. I'm going to stop there before I go into instance types. Are there any questions on this? I know that we've got about 7 minutes left, so I'm going to go through this there's only a couple of slides left. I'm going to go through these fairly quickly. The EC2 instance type naming explained. So you'll find that there's so many different instance types that you can select from, and they all have some really weird name. And so this slide is to demystify how we build that name. Starting from the left, the C, that's the instance family name. And in the next slide, I'll show you a few of the different kinds of instance families that we have. The next one is instance generation, that number. That means every time we bring out new hardware, right, not to replace, but we don't remove the old hardware, we just add the new hardware as well into the data centers. We then iterate the generation number. So this particular example, C5, that's the 5th iteration or the 5th generation of hardware for the C instance family. So generally speaking, you want to get the highest number of that instance family. That way you know you're on the newest hardware. Then we have the N, which is an attribute. Not all instance types have this attribute, but generally it denotes some special capability or capacity of that instance. In this case, N means network. It's got faster network access. And then finally, we have at the end extra large. So this is exactly like t-shirt sizes. You've got small, medium, large, extra large, extra large, etc., etc. This just simply means the amount of resources that is attributed to that instance type. Maybe a small has only one CPU, maybe the extra large has 20 CPUs or 50 CPUs or something like that. So you can imagine there's more resources in the larges and the extra larges. Here is a cheat sheet of the different instance types. This is definitely not exhaustive. There's a lot more out there, but as a general guide, you've got your T series. This is your budget series. You're quite literally paying a couple of cents per hour to run these machines. You got your M, which stands for medium. It is general purpose. It's a good balance of CPU and RAM. You got your C, which is compute intensive, lots of CPU power. You got your R and your X, which is memory optimized or more RAM or faster RAM. You got your D series, which is your dense storage, a lot more disk space or maybe faster disk space. Then you've got your I series, which is your high input output machines, and a few others as well. We've even got, if you're familiar with FPGAs, we even have FPGAs that you can, if you're not happy with the instruction set that we provide, x86 or x64, whatever it is, you can bring your own instruction set and you can throw it on our FPGAs and you can pay dollars rather than tens of thousands of dollars and run it and use it as long as you need it and then stop using it to stop paying for it once you're done. How cool is that? And that brings us to the end of our session. Now, I know I had one question about F5 load balancers. If anyone else has any other questions, feel free to come off mute or throw your questions into the chat. I'll field them for the next 2 minutes before we wrap up.